refractive index of a liquid using a convex lens and a plane mirror. Introduction. If a liquid of refractive index NL is put between a convex lens in contact with a plane mirror, a plano-concave liquid lens will be formed. One radius of curvature of the liquid lens is R, the same as that of the lower surface of the convex lens, while the other radius of curvature is infinite. Let f1 and f2 be the focal lengths of the convex lens and plano-concave liquid lens respectively. Let f be the focal length of the combination of these two lenses in contact. The focal lengths f1 and f are found by autocollimation using a plane mirror. Then f2 can be found from the formula 1 upon f is equal to 1 upon f1 plus 1 upon f2. The radius of curvature r can be found using a spherometer. From the lens maker's formula, the focal length of the plano-concave liquid lens is 1 upon f2 is equal to NL minus 1 into 1 upon r. Therefore, NL is equal to 1 plus r upon f2. Following Cartesian sign convention, both r and f2 of the plano-concave liquid lens are negative. Aim: to find the refractive index of a liquid using a convex lens and a plane mirror. Apparatus: a convex lens, a plane mirror, given liquid, a laboratory stand with clamp, an index pin, a meter scale. Procedure: 1. Autocollimation method. Place the given convex lens on the plane mirror and place them on the base of the laboratory stand. Clamp the index pin horizontally to the laboratory stand and very close to the convex lens. Adjust its length such that its tip reaches only up to the principal axis of the lens. Look down into the lens along its principal axis and raise the index pin gradually until you are able to see its real inverted image. If you change the line of sight, the image of the pin and pin move separately. There is a parallax between the image and the pin. Adjust the height of the index pin till its tip coincides without parallax with the image. In this position, the image just falls in the plane of the pin. When the line of sight is changed, both move together. Measure the distance of the index pin from the lens as f1. It is 14.5 centimeter. Record the observation in the table. Observation number 1. Distance of the index pin from convex lens without liquid in centimeter, 14.5. Disturb the setting and once again adjust the height of the index pin above the convex lens so that there is no parallax between the image of the pin and the pin itself when viewed along the principal axis of the lens. Find the height of the pin 2 more times. Record your observations in the observation table. Remove the convex lens. Put few drops of the liquid on the plane mirror and place back the convex lens on the liquid so as to form a plano-concave liquid lens. Make sure that the same surface of the lens is in contact with the mirror. Again, adjust the index pin such that it coincides without parallax with its real image. Measure the distance of the index pin from the surface of the mirror as f. It is found to be 19.1 centimeter. Repeat the procedure twice. We find f is equal to 18.5 and 18.8 centimeter. Find the mean values of f1 and f. They are f1 is equal to 14.4 centimeter and f is equal to 18.8 centimeter. 2. Radius of curvature. Let's use a spherometer to find the radius of curvature r of the surface of the convex lens in contact with the liquid. Place the spherometer on a plain paper and press it gently so as to get impression of the tips of the 3 legs. Mark these pricks as A, B and C. Measure the distances AB, BC and AC using the scale. AB is equal to 4.0 centimeter, BC is equal to 4.0 centimeter, AC is equal to 4.0 centimeter. The mean distance A between the tips of the legs is given by A is equal to AB plus BC plus AC upon 3 is equal to 4.0 plus 4.0 plus 4.0 upon 3, which is equal to 4.0 centimeter. Therefore, mean distance between the legs of the spherometer A is equal to 4.0 centimeter. Now, let us find the least count of the spherometer. Value of one division on the main scale is equal to 0.1 centimeter. Distance moved by the screw in 10 rotations of the screw head L is equal to 1.0 centimeter. Pitch of the screw P is equal to L upon 10 is equal to 0.1 centimeter. Number of division on the circular scale N is equal to 100. Therefore, least count LC of the spherometer is equal to P upon N is equal to 0.001 centimeter. Now, raise the screw and place the spherometer on the plain glass plate. Lower the screw till its tip just touches the glass plate. Note the main scale reading A and the circular scale division B. Hence, calculate the circular scale reading C and the total reading A plus C. Take at least 3 independent readings for the same surface, each time raising the screw and lowering it. The mean of these readings, Y0, is often called the zero reading or reference reading. Now, raise the screw and place the spherometer on the given spherical surface. Lower the screw till its tip just touches the curved surface. The spherometer should not wobble on any 3 tips. Take 3 readings. Find the mean of 3 readings Y for the curved surface. Calculations. Let us first calculate focal length of the plano-concave liquid lens f2. The total focal length f of the combination of lenses of focal lengths f1 and f2 is given by relation 1 upon f is equal to 1 upon f1 plus 1 upon f2. Therefore, 1 upon f2 is equal to 1 upon f minus 1 upon f1, or 1 upon f2 is equal to 1 upon 18.8 minus 1 upon 14.4, which is equal to 0.053 minus 0.069 is equal to minus 0.016. Hence, f2 is equal to minus 62.5 centimeter. Now, the sagitta of the spherical surface H is equal to mod y minus y0. We have found y0 is equal to 0.011 and y is equal to 0.123. Therefore, H is equal to 0.123 minus 0.011 is equal to 0.112 centimeter. Radius of curvature of the spherical surface of the convex lens R is equal to H upon 2 plus A square upon 6H, which is equal to 0.112 upon 2 plus 4.0 square upon 6 into 0.112, which is equal to 0.056 plus 16 upon 0.768 is equal to 0.056 plus 23.83, which is equal to 23.89 centimeter. Radius of curvature of the spherical surface of the convex lens is equal to 23.89 centimeter. Therefore, radius of curvature of the concave surface of the liquid lens taking the sign convention into account is R is equal to minus R is equal to minus 23.89 centimeter. From the lens maker's formula, we have, therefore, NL is equal to 1 plus R upon F2. Therefore, NL is equal to 1 plus minus 23.89 upon minus 62.5 is equal to 1 plus 0.38 is equal to 1.38. Result: the refractive index of the liquid relative to air, NL, is equal to 1.38. Notes and precautions. 1. Look down into the lens along its principal axis. 2. While adjusting the height of the index pin, always keep its tip at the principal axis of the lens, otherwise you will lose sight of its image. 3. Put only a few drops of the liquid on the plane mirror and then place the convex lens on the liquid with the same surface of the lens in contact with the mirror.